Okay, welcome back. So we're going on to the last section of chapter 2, sometimes called Algebra 2. Why, I don't know. No idea. So graphs of cubic and higher order polynomials. So we saw today what even functions look like. The simplest even function is a constant, then a parabola, quadratic, then a quintic, I think it's called, power 4, and so on. And then odd functions look like a straight line through the origin, because the value you put in, if you put in a, you get f of a out, and if you put in minus a, you get minus f of a out. That's what makes them odd. So a whole family of odd functions look like a straight line, a cubic, and after that it's just a degree of bending. Remember, we had deeper and deeper wells when you have hugging. Now it's interesting if I blow that up. Call this your cubic. We'll come in with a power 5. So there's a very important point, two very crucial points here. 1, 1, this being x cubed, and minus 1, minus 1. Now, we can do this on GeoGebra, but x to the power of 4 will come in here steeper, but then it'll drop off shallower in here, because fractions to the power of 4 are less than this value. Shallower, and then it'll go to town compared to it'll outpace the x cubed. And so it's a kind of boxing up of the function. So you could imagine that if we took x to the power of 99, it would be almost but not quite vertical here. You come right up here and then bend over here, vice versa here. So it would almost be a step, straight up, straight over, and straight up with a tiny bit of curviness. And if you took x to the power, how do we get an odd number with a power? I don't know. So we just take x to the power of 9999999. That's odd. You could model it as a straight up step. Okay. So here we see a double root here. So basically, a few more things. A single root cuts through without the graph doing anything at the root. A double root will always bounce off the root. And a treble root will shimmy through. And just as I've been talking about, so then a power 4 root will come in here at a sharper well. But again, that's not correct, right? My power 4 root, if we compare it to a double root, will be a parabola. No, it won't quite, but it'll be roughly a parabola locally here. And then, so that we call that a double root, we'll say this was at 2. So this is x minus 2 squared appears in the polynomial. Then an x to the minus 2 to the power 4 will be steeper, but then shallower in the local area and steeper again. Okay. So this is a power 3. So we assign this as this factor is x plus 2, power 1. And this factor is x minus 1 to the power of 2. Now you can ask, how do I know it's not to the power of 4? And I suppose if it was, they would have to show us more of the function. Okay, and it would wiggle around again before meeting its end behavior. And its end behavior basically means that if you go far enough away from all the activity in here with the roots, then you only have to look at the highest degree term. So for example, x cubed minus 7x squared plus 11x minus 13. If x is a million, you can just forget about all of these. Or minus a million, you can forget about them as well. So what do they ask us to do? Find an expression. Done. So that looks like minus 2. It's not quite minus 1. What are they doing? This is definitely 3. So we can say x minus 3 squared. I don't like messing around with my eyesight now. I'm just going to ignore the fact that that's slightly off and call that x plus 1, x plus 2. Now, this is a telltale, you see. So one of them must be 2. I have to dilate. I have to double up this. Because I was getting, no, I didn't have to do that, sorry. That was 18 and that was 2. I don't have to double up because this is 18. But there's a problem. Is it inverted? No, it's not. It's not inverted. So it's fine. It's frozen on me. Yeah, so the x plus t and x plus t, that's x plus 3. And a should be 1 according to my calculation. Because I have 2 times 9 is 18. Right, the first two I saw there, the first two cuts were straightforward. They're all single terms, so we're just looking for a dilation factor. I say that because there is no double, there's no bouncing off the x-axis, and there's no chicane through the x-axis, which would suggest something normally, typically in your exam, to the power 3, sometimes 5, but it's probably always power 3 if it chicanes through. So if that's the x-axis and it chicanes through, we'll know that. Okay, where are we? We'll call that x plus 1 using the factor theorem, x minus 1 using the factor theorem, and x minus 3 using the factor theorem. And I will check, is 3 the correct number here? Well, 1 by minus 1 by minus 3 is 3, so this is 1 here, which you leave out. Okay, well, we learned how to do this in class, so this is going to be dead easy. So we'll assume it's monic, and then deal with whether it's not monic based on that 8. I would say it will be monic. So you always want to put the odd one out at the top of your triangle here. So the roots are 1 and 2 and negative 4. Okay, they add together. So we start off this as x cubed, just hopeful, with a bit of hope. And then add them together and you get negative 1, and negate that you get 1. Okay, now we need to get the sum of the two-way cross products. Now minus 8 minus 4 is minus 12, plus 2 is minus 10, and it does not change sign. Okay, now notice that to get the three-way product, you can multiply any. That's already a two-way product, so you can multiply it by its opposite number and you get minus 8, and that'll give you minus 8, and that'll give you minus 8. Okay, and that has to be negated. We'll call it plus 8. Now, is 8 needs to be scaled? No, because it's 8 here, so that's your answer. A is 1, B is 1, C is minus 10, and D is 8. So this is not going to have any constant. Neither of them are going to have a constant. And the reason we're going to see how this is expressed is that this is x with no horizontal shift. This is x plus 3. Call it x plus 0 if you like. And this is x minus 2 here. So we're getting x by x plus 3 by x minus 2. And now we're going to have to use an independent point on them to figure out the green, which is asking what happens when you put 1 in. Well, we can just do them as individual values. 1 went in, 1 went in, and 1 went in, giving me minus 2. Now that's at minus 4. So the green one, I'll use a green pen, is the green one has a 2 here. Okay. And the blue one is 3 times bigger still, which will have a 6 there. So 1, 2, and 3. You do your thing with the triangle and then scale it according to what these are telling you to do. Now, without losing any generality, I'm going to multiply across by 2. So I'll still say there's a, and I won't even change the letter because it doesn't really matter. So I'm going to go 2x cubed plus x squared minus 5x minus 2. Okay. And it crosses the y-axis at 6. Crosses the y-axis at plus 6, which makes a equal to minus 3. So that's it, minus 3 times all that stuff there. Okay, hope you get that. Okay, now we could come up with some new rule for doing our calculations, but we've already said if knowing the roots, we're going with x cubed minus the sum of the roots a, b, and c, plus the product of the cross products, the sum of the cross products, sorry, and then minus the product. Okay, so for that reason, we're thinking that this has a root of 3, factor theorem there. This has a root of minus 1, factor theorem. This is a root of minus 2. Two negatives, we'll put them down. Okay, so the two negatives are down. The 3 is up. And that's a cross product of 2. That's a cross product of 2. And that's a cross product of 2. So I can fill in the monic version of this anyway. Adding them all up was 0. Adding up the circled cross products is minus 7x. And multiplying them all out was 6, and you need to negate that. It doesn't matter how I managed wondering or worrying, did I negate that or not, because it doesn't make any difference. Okay. And we knew this was monic because all of the factors were monic. So A is 0, B is minus 7, C is minus 6. So a cubed adding 2 is the green one. Now, if you're cubing, one of them is if you're doubling it, that'll be the red one. So you don't have to really do anything here. And the blue one here. So it's monics with roots at 0, 4, and 6. And I'm graphing as opposed to sketching here. It's got no intercept and it's upright. It's going to come up, down, and up again, where I'm not playing total, I'm not putting regard to these maximum and minimum values. Okay, well, sorry, I'm only thinking now. You don't have to do the sketch at all. Put 2 in here, here, and here, and evaluate to 816. And put 5 in here, here, and here. And you get f of 5 equals minus 5. Hence draw a sketch of it. So we had those 3 points to begin with. We had 0, out 4 up 0, and out 6 up 0. But now we also have out 2 up 16. So we're going to have to break this 1, 2, 3, 4, 5, 6, 7. So I'm just going to use 4 blocks to be 16. So it's 4, 8, 12. And I am out 2 up 16. And I'm out 5, which is here, down 5, which is just a bit more than that. So quite a few points drawn here. So we're coming up, over and down, and back up again. And they said rough, so they're not going to be going out with a microscope to check how our line progresses. Put 0 in. You get 6. Put a half in, really. 2.5 is 5 over 2. Half take 1 is minus a half. And a half take 3. Okay, the product of the tops is 25 and the product of the bottoms is 8. And that's reduced. And put 2 in. None of those were roots. Surprised they didn't give us a root because it would have been fun. I'll give you one now in a second. 4, put 2 in. 1, put 2 in. Minus 1. And now how would we get on if we evaluated f of 3? Well, of course we'd get 0. we'd get 3 plus 2 is 5. From there, 3 take 1 is 2. And 3 take away 3 is not, which collapses the whole thing, degenerates. That'll do us for now. Okay, see you in the next one.